Our skeleton is a tissue that provides support, strength and protection to our body. It is built up mainly out of calcium. Calcium is captured in the bones via the vitamin K-dependent protein osteocalcin, produced by the bone-forming cells. Bone is built architecturally to give maximum strength in the skeleton. The osteoclasts are responsible for bone resorption. When osteoclast activity is too high, this will lead to too slow bone mass and fragile bones. This is called osteoporosis. Therefore, osteoclastic activity must be controlled. Vitamin K2, in contrast to dietary vitamin K1, it is highly available and bioactive in the bone tissue. Here it is taken up by the osteoclasts. Once vitamin K2 has crossed the cell membrane and entered the osteoclasts, it can do its job. Vitamin K2 acts in the cell as the key to turn off the engine of the osteoclast, which is responsible for bone resorption. It thus stops the process of bone resorption. And finally, the osteoclast will leave. In the bone we have another cell present, the osteoblast. They are responsible to build up our bone. To work optimal also, the osteoblast needs vitamin K2. In the osteoblast, vitamin K2 activates the protein osteocalcin, which is responsible for the proper architecture of the bone and to support bone mass and bone strengths. Vitamin K2 is thus the key in activating osteocalcin. After activation, osteocalcin changes and gets its active form. It is then ready to be transported to the bone matrix. Next, the osteoblasts lay down the osteocalcin on top of the existing bone matrix. The name osteocalcium means osteo meaning bone, and calcium meaning calcium. It extracts calcium from the environment and binds it to the bone. In the case of osteoporosis, vitamin K2 via osteocalcin will repair the bone by filling the laxes in the bone again with calcium. In this way, vitamin K2 acts both on the inhibition of bone resorption, bone loss, and bone formation, bone strength.